Hello, and in this video we're going to have another look at the Kenwood TS-50 and see if we can determine and do a little troubleshooting on why the LCD backlight does not work. Then we'll look at what has caused the failure and how to fix it. So looking at the circuit, we can see we have all four lamps. They're parallel off the rail and two lamps in series. We'll follow it back. You can see we have Q1, which is the 13 volts that comes into the emitter, and Q3, and which this has to turn on for the lights to come on. And what we'll do, we'll start here at the emitter of Q3 and we'll work our way over. And as you can see, the line goes through L2. We'll follow it up. One side goes into the microprocessor, but the other line comes in and 5 volts is fed into pin 7 of CN1. So having a look at the front panel, what we're going to do, we're going to check pin 7 of CN1 for 5 volts. Then we could come here to L2, since this is the only component that is in between pin 7 and the emitter of Q3. So we'll check both sides of that, and we'll check pin 7 to see if we have a 5 volts. So starting off, we'll probe pin 7 of CN1, and this should be the 5 volt source. We have 4.95 volts. Now we'll move to one side of L2, since this is the only component in between the 2 points. 4.92. And on the other side, 4.92. So now we'll move to the emitter of Q3. Let me make sure I got a good connection. Alright, we're showing very little voltage, about 300 millivolts. So let's go back and look at the schematic again. So as we look back at the schematic, we know we'll have a 5 volt line coming to L2 and leaving L2. And since there's nothing else in between going to the emitter of Q3, we have to suspect something on this trace that is has failed. So we'll get a better look at that and see what we find. So what we're looking here is the other side of the board, and you can see that C1 is here, but if you noticed all around the board, everything is black. This looks like a good reason that might be causing some issue with the tracks on the board. It looks like the capacitor has leaked, and all the black that you see is corrosion. And this little trace that you see coming down here is part of that 5 volt rail, and this is a via going through the board. As you can see, it's heavily corroded. So I got a little better close-up shot of that via, and you can see it's really heavily black, and all that is corrosion. So forgive me for the crudeness of my drawing, but I wanted to illustrate this representing the PCV substrate. The green lines is representing the copper foil on the top and the bottom, and the blue is representing the via that goes through the board. And what it is, just a hole drilled, and this little cylinder is put in and usually crimped on both ends. When the capacitor started leaking, it sprayed electrolyte down into this joint, and what it's done is corroded, so there's no longer a contact between the top and the bottom foils. So what I'll try to do is, these vias are usually filled with solder, and that's because of going through the wave process. The solder just goes up into the hole. So what I'll try to do is scrape off some of the trace on both sides and run a piece of wire, very thin piece of wire, through and solder both sides of them, and hopefully this will re-establish the connection needed for the 5-volt rail. So why did the capacitor fail? Well, this is a crude drawing of a SMD cap that is in the radio. In the bottom of this cap is sitting on a little plastic standoff, and the two leads underneath it just protrude out of each side. Now the capacitor has a rubber seal in the bottom, and we all know that the electrolytic capacitors have a liquid inside. They are wet capacitors and electrolyte inside. Well, over time these seals can go bad and the electrolyte can leak out onto the board. Now another thing we need to remember is that the capacitor also has a resistance across it, and it's very, very high. And what happens is, over time, and this thing starts to either leak or dry out the electrolyte, the resistance will go down and down and down. Remember, think of this as a pot of water with a lid on it and a fire underneath of it. As that resistor gets low and lower across it, it causes the capacitor to heat up, forcing the electrolyte out through the vents on the bottom of this capacitor, and that sprays all over the circuit board, and the electrolyte will corrode and contaminate other parts. So what we're going to do is remove C1 and get it off the board, because we know it's leaking. Wait, don't ever use pliers to rip capacitors off the board. I have seen this several times, because doing so you will pull the pads off the board. I've seen people even take side cutters and cut them off, and yeah, maybe you can do that, but you still risk the chance of removing the pads from the board. So what we're going to use is a little hot air. And there we go. So we're looking at the capacitor where it's removed that, and you can see the corrosion on the pads underneath. This pad, like most of the solder has been eaten away, and there's just a little blob was holding the ground side on. It actually looked like it's leaked somewhere from around this side. You can see the corrosion on the board and over these traces. And you notice that this transistor has a lot of corrosions on the pins, and you can even see it right on up on the pin. There's another view of that via that is heavily corroded on the 5 volts line. So what I'm going to do now, I'm going to clean up this via and scrape back some of this coating, solder mask, and we'll heat it up, run a piece of wire through it, and see if we can restore our 5 volts. In this step, you can see that we have removed the solder mask from the end of the trace. Whoops. Got to keep the computer active. And I have put a small piece of bond wire through the via into the other side. Now I'll get this fluxed and bend the little wire over and solder it in place on both sides. Okay, I now have the display board connected back to the main radio board, and I found another via that was also bad on the same line. It happened to be 2 of them, so I went ahead and fixed it too. So now in the moment of truth, if all this even pays off. And there we go. Our backlight is now working. So a lot more work to do to this radio, even here on the display board. I've got to go in there and clean up all those tracks and repair those, and then put an epoxy coating back on top of it so nothing can be shorted out. And then I'm still waiting on parts for the main board. So looks like there will be a part 3 of this radio, and might be in another week or two. We'll see how it goes. Alright, if you enjoyed the video, please give it a thumbs up, subscribe if you haven't, and we'll catch you next time. Thank you.